all for being here for the first in-person Jconf developer, or Jconf dev, Jconf, I don't know how we're supposed to call it, who watched the live stream last year. Okay, so two of us, because I was there as well. So good. All right, so we're going to go ahead and get started. We're going to talk about DevOps and CI/CD. I am the last thing standing between you and lunch. So this 90-minute session is going to stretch to 2 hours. So I think we're going to shut the doors on the last person in, and then we're going to stay here until it's done. Is really where we're at. All right, so DevOps, the term DevOps. When we think about it, like what comes to mind? This is kind of the audience participation. It's the only time that you can raise your voice and won't get a bad look from me. So who wants to kind of give some of the word, when you think about DevOps, what comes to mind? Hey, there you go. All right, that's good. It's a good way to stretch those words out. All right, so developer operations. Who else? Pipelines, all right. What else? GitHub, okay. Collaboration between developers and operations. Good. Any others? Last chance to speak. All right, great. Maybe some of these other words kind of come to mind. When you kind of look at the word map of everything kind of related to DevOps, there's a lot of interesting ones in there. I see government in there. I'm not so sure I agree with that one, but there are quite a lot of words that kind of start to get associated when you think about DevOps. And it does, like every week, there does kind of seem to be another word that just kind of pops up that, kind of joins into the public kind of knowledge around DevOps. And it's probably not hard to think about. Oh, okay. It's like, what's happening here? So you see, we've had words like AI ops that have popped up. There's GitOps, MLOps, DevSecOps. There's also DevTestOps, which I recently saw. I don't feel really great about that one, considering you're supposed to already be doing testing. Why do we have to have a whole nother term for this? But that's my own little pet peeve. There's TreeOps. Okay, not really. TreeOps doesn't exist, but at the rate we're going with all the different terms that pop up out there, who knows, TreeOps might become a thing. And I did, in fact, when I was creating this talk, register the domain devtreeops.com. So who knows? Now that I've spoke the word, I have the domain name, I've got to use it. So I got to probably do something with it. But I also have like over 20 domains, I think 25 now, that are sitting there doing nothing. Hi, I'm Jeremy Meiss, and I have a problem. As I said, my name is Jeremy Meiss. I'm the director of DevRel and Community at Circle CI. I have been working, spent over 27 years in tech. Yes, I did start when I was 3 years old. Don't let the color in my beard fool you. I was an early bloomer at 3, getting started in tech. I have worked in just about every functional area within an IT organization, everything from support to system admin to network admin to program management, project management, application developer, database, systems analyst, network admin. I think I mentioned. I've worked with just about everything out there over the last 28 years. But the last 10 of it has been heavily involved in developer relations and community. All right, so when we think about all these different words out there, it does, kind of tend to muddy the waters a little bit. So we're going to kind of walk through, what DevOps is. I did a search, found out on the great search engine Amazon that evidently DevOps is a line of shirts, specifically male athletic shirts, moisture wicking, compression shirts, sleeveless even. So if you want your sleeveless DevOps, you can purchase that, or multiple colors. So you can have a colorful DevOps. So I think that's just it. We just need to go out to Amazon and we can now purchase DevOps for our organization. The next time somebody in your organization says, "Hey, how do we get DevOps?" Just send them to Amazon. I'm sure that will help. But DevOps itself does kind of trace itself to a concept that back to even agile development, and we're going to walk through come back to that here shortly. but we've had, it also came out of all the inefficiencies that we tend to have, that I say that existed in the mid-2000s, but if we're really honest, like we've always been inefficient, especially with tech, or with leaf blowers. So, that's the next industry to revolutionize with DevOps, evidently. But really it does trace a lot of its roots back to Henry Ford and his flow production model that he started in the 1910s in producing vehicles. And then it was kind of expanded on, taken and improved upon by Kiichiro Toyoda in the 1930s when created the Toyota production system. And that really, kind of revolutionized, Japan, but yet it was kind of stayed in Japan. The ideas and philosophies around that was really kind of, transforming Japan, but the U.S. industrial system was still kind of working through a lot of the Henry Ford system. But in the 90s, the book, When the Machine That Changed the World, was published. It documented kind of what the Toyota production system was and how they were working as a company. And they kind of coined this term lean. So when we think about, the lean development system or lean production, it comes out of this. The software development world itself, though, was kind of relatively slow to jump on the bandwagon until about 2001 with the Agile Manifesto, which was coined by 17 white men, which, if we really kind of pause and think about it for a second, it seems like white men are the only ones that come up with manifestos. And I don't think you can find a manifesto that wasn't done by white men. So I feel like there's probably something we should examine there. But they were looking for ways to develop software, collaboratively, instead of within the silos. And so we're going to come back to this, but this kind of sets the stage. So we'll come back to the Agile shortly. In 2009, at the O'Reilly Velocity Conference, you had John Allspaw and Paul Hammond, who were both in engineering at Flickr, and they gave a presentation titled 10 plus deploys per day, Dev and Ops Cooperation at Flickr. And from that point on, I hate to say it, that a revolution started, but things started to happen. A lot of people started to question that. A lot of people started to say, we want to do this. Throughout their talk, they continued to make kind of this case on why communication and collaboration between development and operations was vital, and kind of really did spark this kind of appearance of what we now know as DevOps. One of the things they described was kind of this stereotype that devs and ops tend to do about each other, around typical development processes, has all the finger pointing, all the blame game that happens. It's not my code, it's your machines. It's if you wrote better code, my machines would run better. All that stuff that kind of tends to happen. And their presentation really made this case that the only really rational way forward for us and for efficiencies within our organizations was to be, have a seamless, transparent, and fully integrated application development and ops processes. Patrick Dubois watched a stream of that talk, and he really identified with the situation that those two were describing. He was a consultant in Europe, in Belgium even, and he had already become frustrated as well with kind of the developers and operations engineers always doing the finger pointing and passing the blame onto each other. And so he started to be encouraged by others on social media and decided to kind of form his own conference, which he called DevOps Days. It was formed in Ghent in 2009. And DevOps itself, if we go back even for a second, now had, that was 2009. So we're 13 years on from that time. And now there's been hundreds of DevOps conferences around the world that have sparked up in communities and large cities to bring people together. How many have been to a DevOps Days? One. Okay, so two. Two of us here have been to DevOps Days. Great. They are generally a good time. A lot of good information, a lot of great way to connect with others in the space, learn more to be able to take back. But, all right, moving on. So DevOps itself is this union of people, process, and technology to continually kind of provide value to customers. It does combine the software development, so that's the the dev side, with IT operations, so that's ops, with this aim to kind of shorten the software development lifecycle and provide continuous delivery with high software quality. Like that's the goal. Continuously deliver within your organizations and have high quality. But it's about culture first, not the tooling. No matter what people tell you, like you can't just have DevOps by going out and buying some tool. Years later, Patrick Dubois would describe DevOps in this way, as it is, everything you do to overcome the friction that gets created by silos. All the rest of it, after you've recovered from that friction, is just plain engineering. Though I do have to kind of retract when I say you can't go buy it, because evidently my friend Matt Stratton says that you can't buy it, but he will sell it to you. So if you're really looking to purchase DevOps, just contact Matty Stratton and tell him that I didn't send you. But we've had, there's a lot of really good resources here to kind of dive deeper into, DevOps as culture. And each of these books really kind of jumps on it from a different perspective. So you have the DevOps handbook that was written, really lays out all the different processes and procedures and what it looks like for the culture within your organization. Accelerate, done by Dr. Nicole Forsgren and Jess Humble, Gene Kim. They dive into the science of organizations and the science of what it takes from surveys, but actual data, to have a high-performing team, which eventually kicked off. You've heard the DORA report. That is, DevOps report comes from this book and the work that they've done, and it's now been a regular thing. Friend Emily Freeman wrote DevOps for Dummies. It's probably one of my favorites, just because it really breaks it down in simple terms and kind of really sets a good baseline for you to start. And then if you're somebody that likes to read kind of fiction that is, or nonfiction that's masquerading itself as fiction, Gene Kim wrote these two books. The first one was the Phoenix Project, the next one was the Unicorn Project. And they both deal with organizations, real organizations, named have been changed to protect the innocent and foolish, and of how, just tells a story. And in the process of doing so, lays out what it looks like to transform organizations. So, the dev side is the Phoenix Project, the ops side is the Unicorn Project. So I highly recommend you get those books. They are great, easy reads, but you're going to learn a lot. And I refer back to them a lot. So as we think about kind of this DevOps lifecycle, we tend to visualize it. This is your typical visualization of how you're always consistently iterating. You're going from your planning, your code, to build, test, release, deploy. Now you're operating it, and then you monitor it, and then it goes back to plan. Like, it's just this cycle, never-ending cycle. So there's that, how we tend to visualize it, and there's the hope of how we implement it, but then there's really kind of the reality of how it often ends up within our organizations. It never really goes to plan. You still do kind of tend to get some of the finger pointing that happens, even though you really don't want that to be the case. You do tend to kind of still get there. All right, so also John Allspaw, he kind of, he calls it work as imagined versus work as done. We all have a great idea of how we're going to get to someplace, but it always ends up that it's never as simple as we think it is. So we're going to talk now about what really activates DevOps for teams and kind of helps them realize their potential. Software delivery has never been more critical to the success of business in every industry. Every company is now a tech company. It's never been more complex, though, because expectations for delivering high quality software incredibly fast continue to skyrocket. Yesterday's exceptional product experiences that we've had kind of tend now to be expected to be what they were and be more beautiful, intuitive, powerful, affordable. So it's everything, just those expectations continue to go, but yet it's been so even more critical for high quality software delivery. But the landscape of tools, platforms, architectures, constantly evolving. If you look at, this was from a few days ago, what the CNCF landscape looked like. It's probably going to change at any moment. This is constantly evolving. So when we think about like the landscape of what it means to have the different tools and the platforms and the architectures all together, like it just gets, there's this rapid pace of change, it's growing complexity. And so how can engineering teams not only succeed, but how can they beat out the competition? And this is where I would posit that, not posit yet, if we imagine that you're getting ready to ship something. So you've been spending weeks, months on a project, you're now ready to release it out in the wild, and you're kind of getting ready to hit that button, and you're ready to release it. So you hit the button, and it gets released, and then what generally happens after you click that, hear that click, when you've pushed the button of the mouse to now release your software. What's your general feeling? That's the second point where you can chime in with your thoughts. Okay. Yep. Okay. What else? Anyone have fear, dread, worry, a little acid buildup right around here that, oh, I hope this works. And then you kind of get the silence of, well, okay, now are the phones going to start ringing? Are the, executives going to come running in here and scream bloody murder and, everything go to shit? What's going to happen? You have a couple responses. You can either, sweat it out, wait, and see if things blow up, or you can just go home, take a nice nap, enjoy on the weekend. And I love this here because that means we've deployed on a Friday, which you should be free to do, and you should feel good about it. But the only way you're going to do about it is we'll get to why that. And also, by the way, the whole don't deploy on Friday is not really a thing. I have the data to show it. People still deploy on Friday all the time. The days don't matter. The difference is whether or not you have high quality software and you have the right processes in place to make sure it happens. And people that say they don't test in production are lying, because what's the first thing you do after you deploy a software? Maybe to your phone, you pick it up and see if it works. You're testing in production. So, all right. So now I've just completely blown up the world and, fun. All right, but being able to do this, go home on the weekend and do nothing, and enjoy it after you've just deployed something, boils down to automation. The ability to do that, automation really drives it. Some would say the challenge of automation, though, is that there is that risk of machines misbehaving. The fantastic documentary series Terminator. If you've seen that documentary series, that kind of really shows how things can go bad. But I'm pretty sure we're not going to end up in this robot overlord world. I did say pretty sure, can't be exactly sure, but after the first last few years that we have had, anything is possible. So don't quote me on that. But we can kind of agree that automation malfunction really is, it can ruin your day, but it's usually a result of things that we do. Robots still are just doing the things that we've programmed them to do. There's a failure, something that we've done. Who here knows what PEBCAC is and has heard that term? Okay, I'm just going to assume those that aren't raising their hands that they're asleep, and hopefully we all have heard the term PEBCAC. Problem exists between computer and, or between keyboard and computer, or customer, that's what it is, customer. Chair, that too. I've heard multiple for the C. It's not computer because it's never the computer's fault. But it is usually our fault. Pretty much every software failure is rooted in a human failure. So going back to CI/CD, we talked about, it's rooted in agile methodology, embodies this culture of a team or a company's commitment to automation and DevOps principles, which generally it is going to contain a set of operating principles and a collection of practices which enable dev teams to release quality code more frequently and reliably. So when we think about continuous integration, it is the practice of merging all developers' working copies to a shared code repository. Continuous deployment, it is really just basically automation. It's that practice of automatically deploying new software releases to the target environments. Now, thinking about agile methodology, which is where this really kind of roots itself in. Those methodologies generally contain a set of operating principles. That Agile Manifesto was based on 12 of those principles. It had a collection of practices which really kind of enabled dev teams to release quality code more frequently and reliably, which is the goal of DevOps. Those principles have really brought about a lot of the different agile software development frameworks that we can kind of see. You see things like lean software development, Kanban, Scrum. There's also everyone's favorite casserole, Scrumban. So if you really want a heaping pile of agile, there's the Scrumban. But all of those have really brought about a variety of the different agile software practices. So there's things like the planning poker, which I will 100% admit I had no idea what the frick that was. We used to just call it estimation, or just I don't even know it was estimation. Somebody had to say, oh no, that's just planning poker, and you say what you're going to do and you're going to plan it. I'm like, oh, okay, whatever. Anyways, but one of the things that did come out of the agile movement, though, as I previously mentioned, was continuous integration. And the main contributor to that was a guy by the name of Grady Booch. Who here has heard of Grady Booch? You should follow Grady on Twitter. I think it is Grady Booch on Twitter. He is he's amazing person. Has really put in place or driven a lot of the things that we now call kind of normal. He was one of the originators of object-oriented way of doing things, and he was the founder of UML. And he kind of first proposed this kind of idea of CI back in 91 in his book, Object-Oriented Analysis and Design with Applications. His method advocated for a more frequent use of classes and objects in programming in order to really simplify the design of how we were doing things. But his version of kind of the continuous integration didn't suggest that we were releasing multiple times per day. But in 97, along came this book. Who remembers this book? Extreme Programming. It was also called XP, not to be confused with Microsoft XP, as much as they might want you to believe it. But the crux of it was really kind of taking all of those things that we were already doing as a result of Grady, and then taking those and writing and releasing software in a more extreme way, which is why it was called Extreme Programming. We were really creative back then. So that brought on these shorter release cycles, extensive code reviews, which we now kind of call pair programming, unit testing, acceptance testing. All of those things came out of this book. We have a lot of that to this book to thank for it. And from here, we kind of got a lot of methodologies that built on this. But the one goal in mind was to really kind of make things easier, to write clearer, high-quality code, and get it out to the users. So while we recognized that all of this needed to happen, we really didn't have a lot of the tools to make it happen. But in 2001, there were some tools that were popping up, but in 2001 was the first kind of open source tool that came around that made continuous integration easier to actually do. You could roll it up. First time you could take this with cruise control. You could put it on your own architecture. And now you had a system within your environment to start doing this continuous integration. When you look at it now, it was pretty primitive, but in 2001, it was revolutionary, very game changer. It is still if you search around on the internet, you can find some projects that are still stood up that use it, but there are better ways. Like I said, it was revolutionary. It was kind of something that it allowed you to automate the management of your builds. But it was the first to actually integrate into your IDE of how fully into your IDE. So it was based on whichever tool you had. So if you're programming in Ruby, then you had a Ruby version of for instance of cruise control that would integrate with your IDE. If you were doing Java, you had Eclipse. It worked inside of there as part of a direct integration. And then, who's heard of Hudson? Okay, a few more. Hudson came around in 2007, 2008, was created by Kosuke Kawaguchi, who worked for Sun at the time. And since it was created there at Sun, they kind of took ownership of it. They decided to trademark the name Hudson. Once that happened, people behind Hudson Fort and created Jenkins in 2011. Meanwhile, Sun ran Hudson into the ground because no one wanted to use it anymore because it was affiliated with Sun. They wanted to use the actual open source version, which was Jenkins. So Hudson pretty much just disappeared about 2000. It was donated to, forget what organization, and became, it pretty much died in 2017, whereas Jenkins lived on. And Jenkins is still very widely used today. It does support a lot of different languages, and it can be made to do just about anything you want it to. It does have an enormous community around it. So when you do run into difficulties, chances are there's somebody else in that community that's dealt with that as well, probably comes up with a fix and deployed it. It is still community ran, but not a whole lot of innovation is really happening with Jenkins. It just works. It does. It's stable. It's relatively secure. It is still pretty popular. But the downside to something like Jenkins is that the way that we build software generally is changing. If we think about a lot of the tools and services we use, they tend to come from cloud providers. Cloud is very much a way that general business has moved. There are exceptions to that, but even those exceptions are starting to realize that there are ways to still use cloud within their environments. We've seen a lot more of finance, big enterprise starting to use cloud more. And so Jenkins is starting to kind of feel some of that weight because that means you have to have your own organization, have an actual team to run this. You have to run your own infrastructure. There's a lot of challenges with it. So there's been, as a result, we've started to see cheaper options that are available in the cloud. Circle CI, it's the only time I'm going to mention really my company. We are one of those, but there are plenty of other cloud-based solutions out there for doing CI/CD. They're built so that you don't really have to worry about the infrastructure. You don't have to, worry about the, all of the CI piece. You just go back to doing what you're, building your business, building your software. These cloud providers, they all support, dozens, pretty much every language out there. They already know how to work with other cloud native technologies. So if you're doing things with Kubernetes or you're, wanting to do observability and all that, they already have that stuff. You can already work with them. They already know how to do it, and they've already kind of built in the integration so that you don't have to manage that. So using a cloud service for your CI/CD is both more flexible and it becomes very much lower maintenance. Now, I'm going to go back a little bit here. Who here has ever used Visual Source Safe? Microsoft's Visual Source Safe. Raise your hand, proud. Just because no, there really is no pride in the fact that we used to use Visual Source Safe. Microsoft acquired that from One Tree Software in '94, and then they stopped developing something called Microsoft Delta, which nobody had ever heard of, and still to this day are thankful that it disappeared. Microsoft decided, hey, we're just going to take this. One Tree Software actually was building this, I think it was called One Tree Source Safe, or One Tree Software Source Safe, something like that. And they actually had multiple versions. They had Mac, and they had Linux, and they had Windows, and they had a variety of them. Even they had, I think, stuff that worked with other, not your traditional Linux, but some of the more regular Unix systems. And as soon as Microsoft bought it, they killed all of those and only went with the Microsoft version. Go figure. Other companies kind of stepped in and kind of picked that up. But what Visual Source Safe did was, they tried to attempt to keep you from overwriting code that others were working on, and they used a virtual library, which was kept locally, of the software code that you were working on, which in theory, sure, fine, it works, but usually it kind of devolved into going, and you'll remember this, devolved into you wanted to work on a file, and so when you would work on a file, you'd want to check it out, which means now it copies that to your local machine, puts a lock on the file where it's actually at, and saying that no one else can use it because I've locked the file. You're supposed to lock the file you're working on, as opposed to locking multiple files or a directory or the entire code base. Because if you locked that meant nobody else could work on anything else. So whenever that would happen, I wanted to work on a file and so has it locked, I'd have to pick up the phone, call them. They're not at their desk, go to find out they're on lunch, or heaven forbid they are on leave or on in Hawaii on the beach for 2 weeks and you can't reach them. So that means you got to put in a help desk ticket, and that could take just as long to try and get the code unlocked. Highly inefficient and was not a great way to do things. But the idea was there. Today we think about an actual VCS is that you can work on multiple, all of us could be working on the same file. And because of the way that we build systems now, you can handle that merge a whole lot easier than having to just completely have one person working on a file. This is what it tended to look like, is you'd have, everybody had their own versions, and then you had to try and merge it into the code base and hope that it didn't break anything, because there was no way to take all of those things and put them in together. And that's where things really kind of started to mess up in the traditional or the older, less productive ways of working. But there's a better way. We talked about CI. Again, it's the practice of merging all developers' work into a shared code repository. When you do that, it does, you're doing all those changes often, it keeps the team informed on the code base and helps resolve conflicts a whole lot easier, because you all are working on the different versions of it, and so you can see where each of you are at any point in time and roll it back really easily and help deal with future conflicts better. You can also run your automated tests to validate your builds, ensuring that your quality code gets passed, and that you're only pushing quality code. You can integrate, making sure as part of continuous integration, when you've done those things, that you're only integrating tested code into your code base. Goes back to that quality, so you're pushing fast and making sure that you have high quality code. And then all those changes get frequently merged into your release branches instead of waiting for doing it once a month or 2 months or 6 months or yearly. I worked at Sprint for 11 years, and we can have horror stories on how often it took us to release things, or how long it took us to release things. Now, how many of you have heard of the term fail fast and often? Good. If you haven't, it is a very, it's a very, very important thing. It's really, when CI gives the development team the ability that when they're working on things and they're pushing it, the quicker you get the signal that things aren't working, the quicker you can fix it and make sure that you're not pushing bad code. And so, when stuff is broken, the ability for you to know that as soon as possible, the better. It's just better for you. It does lead to faster fixes and better quality delivery of code. If you're in a organization that says that you should not have any failures when you're developing code, come talk to me after. I'm sure there's plenty of other companies out there, and I don't say that in jest. People make mistakes, and when we're developing, innovation comes from making mistakes. So, we'll move past that. Continuous integration also does kind of get us to this speed of delivery that, once you're writing your code, you're pushing it upstream, and automation is going to take over, and then you're validating those builds, ensuring that you're only passing quality code. So this integration just really gets you to a speed of delivery that can give your company the edge you need. Now, again, we talked about continuous deployment is really, it's really just automation. The overall chain of process kind of gets into a pipeline, helping you release your software faster. The goal of CD comes down to producing software releases that are automated, they're efficient, they're reliable. You can reproduce them at any point. You can verify them, which again, continuous testing should be happening as part of those things. But that's the faster release cycle. Also, it means that you're delivering smarter releases, and you're lowering the risk to your release process when you're doing it continuously, as opposed to pushing larger changes all at once. It's easier to just continuously deploy those smaller changes. It's less risk. You're also going to make sure you get higher quality code because you've already gone through the continuous integration and making sure everything's checked and ready to deploy, as opposed to just dumping a bunch of stuff in. And then, using all these mechanisms, you can lower cost by, the time for your developers, the costs for, all the different billable items that might be happening, like time spent delivering to multiple infrastructures, like staging and QA and, and then to production and then release and all that. So being able to, with continuous delivery, it does give you the edge that you can save some money. So now when we think about, let me ask this question. So who here is already using in their organization continuous integration of some sort and continuous deployment? Good, fair amount of you, almost all. How many have, it's relatively new in your organization, like let's say within the last year? More than 2 years? More than 5? Or you've just been, everything you've known has been some continuous, okay, good. That's a great answer. So when you think about when you want to implement it, whether it's in a small team or a large team, CI/CD really, it is important to get that pipeline set up as early as possible. So if you think about building a new project, building out what it means to get your test added as soon as possible, continue to innovate, build with confidence. Who here has heard of John Romero? Who here has heard of ID Software? Wolfenstein 3D, Doom, and Quake, and all of those. Counter-Strike, all that. That was done ID Software. John Romero was one of the creators of that, one of the original, and has been a part of 60 plus software games over his time. Was at a conference, Strange Loop, last week, and he actually talked about testing. He talked about development, and one of the things that he said was, and I meant to get it up on the slide, and I forgot, but one of the things he said was, when you're developing, when you see a bug, fix it then. Don't make a note and say, okay, we'll come back and fix that later. Fix it then. You have the best opportunity to fix something that your users are going to have down the line if you do it now. Otherwise, you're just relocating your problem. You're creating tech debt. So just fix it then. That's part of kind of continuous integration, is you're finding the problem, you're fixing it, and continually integrating new good quality code. Another thing he also said is, don't do demos. Don't do previews. Just build the thing. Don't try and do a game and say, okay, or a program and say, hey, I want to do something. I'm going to test it and see if anyone wants. Just build it. Don't stick around. Don't waste all that time. Build. So, anyways, great stuff. All right. So once tests do get added though to the pipeline, you can continue to innovate, build, iterate, all of that, and continue your pipelines. You can make sure your code gets in. And then, developing this continuous deployment workflow, part of that, gets that automation. And when you're automating your software, it's building, testing, deployment. It is then important, once that's been automated, from those manual tasks, to get back to work, building the features that your users are caring about most, and letting, the delivery, all of those things you've automated, just pick right up. All right, it's important to make sure everybody's on the same page when you're starting to work with CI principles, CI/CD principles in your organization. Making sure everybody's reading from the same playbook is important. Otherwise, you're going to have everybody going off in different directions, and you're going to really mess things up. So everyone in the org has to know what the processes are and how they're going to do things on a day-to-day basis. Continuous integration is also just not about implementing some tool. It's about changing how the development team in your organization works. So, it is, for some, it's a new mindset. So making those culture changes on anything can be big. So it's important to start with a small team. Maybe it's your team, starting to put in new checks. Maybe you're going to start using a new way of process around how you view your testing, or your maybe you're doing accessibility. Anything you're doing, you need to make sure small change that you always start small with those changes that you're putting into your pipelines. So do what works for you. Know that DevOps might not be the right solution itself completely for your organization. It might be starting small. Going back to the previous principle. It's also important to know that you're not the Netflixes. You're not unless somebody here works for Netflix or Google or any of those other big organizations that tend to be viewed as the poster child for good software development. You're not them. You're you. And so it's important to kind of understand that these principles around DevOps, around CI/CD, you have to kind of mold them for you. What works for you is not probably going to work for the Netflixes, and what works for Google is not going to work for you. So get back to what is your company's core strategy, and how does this fit in to help amplify that and build that DevOps culture. And then measurement. It is always important to measure. Measuring for the sake of measuring, though, is not helpful. So know what your baselines are. Getting accurate measurements for where you're currently at. So your dev cycle takes, X amount of time. That's a good thing to kind of know as a baseline. So do that before you kind of get a SRE involved into, maybe your development team. Understand what your baseline is, what you're starting with first. And then you're going to be able to see whatever change you make, whether it becomes effective. So that could be, you're using, maybe now you're starting to use as within the applications you're building, you're using some new framework. Well, understand what the baseline for how long it took you to develop and roll a change out, and understand what that is before you implement some change, so you know whether or not it's good or not. Otherwise, you're just throwing darts at dartboard. One of the things that we saw is when a lot of the agile transformation started to become the buzzword, and everybody wanted to become agile, and many companies kind of adopted the stand-up. Hey, we're gonna have our daily stand-up. We got to do this, and that's how we're going to be really, really effective. But they didn't really understand why they were doing it, or measuring whether or not it actually had a positive effect on the team. And so we have teams out there that have stand-ups that doesn't really do what a stand-up is supposed to, and everybody just spends 5 minutes talking about what they did last night. So it's important to understand why you're doing something and establish that baseline and make sure you know what's actually changing. The cadence that you deliver software really should be dependent on your team, what you're building, and your business needs. So making changes to your project with kind of automated testing workflow means your organization is no longer going to be blocked by waiting for things, because now it's automated. So with a fully automated software delivery pipeline, it's up to you how frequently and when updates are delivered to your end users. And that's going to be dependent on your company, what you're doing. We have seen a number of benchmarks when it comes to CI/CD that are important to keep in mind. So the first being throughput. That is, how often you're pushing changes. That should be as often as your business is able to do it. Duration of those builds should be less than 10 minutes. This is a recommended benchmark, as we've seen looking at hundreds of millions of workflows, jobs being done over the last few years. This is what we've seen as a high-performing team tends to function in this way. But that does mean that's very dependent on your organization. If you are building Java builds. How many here building, if they're building Java, or even, it doesn't matter what they're building, how many, your build duration takes longer than 10 minutes? Okay? And that's okay. If you've, some things, whether it's, if you have to compile whatever you're building, generally that's going to take longer than deploying a website. So understanding what it is that you're building, again, it comes back to that baseline. Know what it is now, and then see where you can make those changes. Maybe you run jobs in parallel. Maybe you are, relocating, a process where you take your artifact and push it somewhere else. Maybe you're doing that at the end, or that's something that only gets done on occasion. There are things to shorten your duration for your builds, but you can only do what you can with what you're building. So it's important to understand that. So while we say this, a duration, they should be less than 10 minutes, that also means that it's going to be what's best for your organization, what you're building. So, and then success rate of your production branches should be over 90%. We do not recommend that your non-production, so your dev branches or your feature branches, number one, that they should really be tracked from a success perspective. But number two, if you do want to track them, which can be helpful, that you don't have a KPI or include those in your actual success rate. Because the reality of, go back to innovation, like when you're building something, you're going to make mistakes and you're trying new things. It's going to break. That's part of development. So that's okay. So when we think about success rate, that should be on your production branches where you don't want things breaking, not your development branches where things are going to break. And again, it goes back, if that's a KPI that you have, we can talk later. And then, mean time to recovery. How long does it take you to recover from from a failed build? Should be less than an hour. Is what we see as kind of that average, the mean time. But that also makes a difference based on your duration. Because if your builds alone take over an hour, then mean time is going to take at least an hour for you to get a build get done. So again, that comes back to what is your baseline within your organization? What are you building? Adapting these benchmarks to your organization. There is, I forget the guy's name, one of the leaders at ThoughtWorks actually said that, had this big long quote about one of the advantages or one of the easiest ways to get back to a green build is just roll back to the last successful build. Roll back there, and then get back to fix things quickly by doing that, and then go figure out what went wrong. Don't keep trying to push these things that fail. Just go back to when it was green, fix it, run it in your dev environment, and then move forward. Just a little note. Okay, so think about better ways to make your CI/CD practices better. Not the best practices, but better practices. Making sure you have a rigorous testing culture within your organization. It is one of the most one of the most important things that a successful company can do when it comes to software development. Your team does need the confidence that the code that they're pushing is sound, and the only way to get there is to have good testing. Getting a red build, which just means it fails, or there was an error, is one of the most important signals that a developer can get. So again, coming that fail fast and often comes into play there. Also making sure that your testing environment mirrors production as much as possible. That seems like that should be normal, should be like, well, yeah. But you'd be amazed at how many environments don't mirror production. So make sure that everything is on the same page, whether it be the database, the web server, the correct artifacts being used, etc. Another one is do a lot of pair programming. Do a lot of the better kind of ways that we've started to see it for software development. Help the newer developers learn. Older developers or more seasoned developers is maybe a better way to say it. they can learn just as much from a new dev as a new dev can learn from a seasoned dev. So it's important to use better coding practices like pair programming to get to better CI/CD and better overall code quality. Also, ensuring the entire software development pipeline is fast and efficient. You want to make sure you're automating that deployment workflow wherever possible. Again, automating is great, but if you do require a manual step, automate everything up to that point. If you require somebody to push a button to deploy something, make sure that everything up to that point has been automated. All right, we think about streamlining. There are services out there that kind of do it if you're developing something that could be pushed out to the web. Heroku does this as well. Things that, if you're building applications, there's Vercel, there's Netlify, there's, Heroku and others that all kind of help streamline that process. Services like ours and others also can do that as part of the actual CI and your actual CI config and pipeline can do that as well. All right, so I talked about the DORA report. We've been running a report now for the last 3-4 years that takes all of the data that we see across all the builds that get run and has put that through data analysis and has actually created what we call the State of Software Delivery Report, which can be found here. And we've done it for the last, we just did it the third year. So we did it in 2019, we did it in 20. Towards the end of 2020, when we saw, during the pandemic, it took and analyzed the change that we saw within development as part of the pandemic, the way everybody was now at home. What did that change? And it's a very interesting piece in that. And then this report in 2022 took actually 2 years of data. We wanted to see, okay, now we have change that happened as through everybody going home and with the pandemic. Now we have a big data set. Let's look at that and see what's changed over time. And so this one also deals very heavily on what it means to have a high-performing software team. So important to take a look at that. Highly recommend it. And you can download that without actually filling out any form. So it's not about grabbing your data. Just read the report. It's fun. All right. And if you have any questions, I'll be here. I do have to leave tomorrow for another conference, so I'll be here today. Feel free to reach out to me. I do have some stickers up here, and you can follow me on all of those. And if you have some feedback and whatnot, want some swag, reach out or fill out the form. So thank you very much. Any questions? I mean, we have a couple minutes. Any questions? If you want to come and talk about Microsoft SourceSafe and other terrible tools we used to use, feel free to do so. Yeah? What was the turtle? Was that SVN or was that, started with an M? What? Hear someone say it? Okay. Okay. So yeah, I think that, I remember seeing that. I couldn't remember the name, so. Yeah, SVN was great. It was a great improvement. I think Git, took that to the next level. But SVN and some of those back then were a whole lot better than Microsoft's Visual SourceSafe and all that. So horror stories. So, all right. Thank you very much. Appreciate it.